Okay. So again, we already look at the definition for random variable. So in Malay, we call this one as pemboleh ubah rawak. So, so it relates to the concept for probability. Okay. So when we mention about probability again, you will have a sample space. Okay, sample space normally we denote by S. Okay. So your set S normally lists all the possible outcome. Okay, which is the result from your experiment. Okay, so the idea of using random variable, because this one, so normally when we have a sample space, for example, let's say we tossing a coin. So a coin, we have the outcome, for example, let's say head and tail. Okay. So normally if we have tossing for 3 times, okay, tossing for 3 times, okay, the outcome you will have either head, 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 tail, head, tail, tail, or you can have all 3 is the tail. Okay, tail, tail, tail. Okay. So again, let's say if we are concerned with the number of hits, again, the number of hits. So again, it is much more easier if we assign a numerical value. Okay. For example, let's say if we have a random variable, for example, let's say we denote as x. Okay. X is your random variable. We denote as the number, or we define it as the number of hits appear. Okay, the number of hits appear. So it can be either no head appears, only 1 head, 2 head, or 3 head, because we toss the coin for 3 times. Okay, the maximum number that you can have is 3. So again, we assign a numerical value. So a numerical value in this case, you can have either 0, which is represent no head appears. Okay, only 1 head, 2 heads, or all is 3 heads. Okay, so we assign a number. Okay, so that one we call as random variable. So in this case, your random variable we denote as capital X. What is your capital X? It denote the number of heads appear. What you want to find in this question. So in this case, we are concerned with number of heads. So that's mean we assign or we define a random variable X as the number of heads appears. Okay, the values is it can be either 0, 1, 2, or 3. Okay, the maximum is 3 because we toss this one for 3 times. Okay, it can be either no head, only 1 head, 2 heads, or all event we have all 3 heads. Okay, so X, capital X is your random variable. Okay, your small x. Okay, small x is your value 0, 1, 2, 3. So this one is your value. Okay, normally you want to find probability X, capital X is equals to small x. So you will find probability X equals to 0, probability X equals to 1, and also probability X equals to 2, and lastly probability X equals to 3. Yeah. So again, we define a random variable again. So it is actually a function. Okay, a function that assign a real number, okay, to each outcome in the sample space of a random experiment. Okay, a real number. Okay, any values. Okay, assigned for each outcome in the sample space of a random experiment. So we define this one as a function because normally you will write, okay, the same thing, fx, or you, okay, sorry, fx equals to probability x equals to x. Okay, your fx is equals to probability x equals to x. So it is a function that assigns a real number to each outcome in the sample space of a random experiment. Okay, this is the example of random variable other than coin. Okay, for example, you have marbles. Okay, marbles are drawn without replacement. Okay, you have 3 blue marbles and 2 red marbles. Okay, what you want to find? You already find that your X represent the number of blue marbles. Okay, number of blue marbles. Okay, if we list all the outcome, you want to choose 2 marbles. Okay, 2 marbles, let's say lah, we represent it in terms of tree diagram because this one is related also to the probability. Okay, you have either blue or red. Okay, let's say you have blue, red. Okay. And then you have blue and red, blue and red. Okay, but the process is again without replacement. That means you take one and then you didn't put it back, okay, without replacement. Okay, so the number of sample space will reduce by one if you want to find the probability. Okay, let's say you just want to list all possible outcome. So you can have either blue, 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 red, red, blue, or red, red. Okay, this is all possible outcome. Okay, you define your X represent the number of blue marbles. Okay, the number of blue marbles. So that's means your small x, your value. It can only take either no blue marbles, you have red, red, okay, 0. Only one, either blue, red, or red, blue. Okay, or both is blue marbles. Okay, so 0, 1, 2. Okay, so that is your values. Okay, your x is equal to 0, 1, and also 2. Okay, so this again, your possible outcome, you list all sample space. This is your values. Okay, your small x is 0, 1, 2. What is your capital X? Is number of blue marbles. Okay, let's say if you want to change your x atau your y is number of red marbles. Okay, number of red marbles. Okay, it's the same thing. You want to find your small y. Okay, because we choose two marbles are drawn without replacement. So again, it can be either no red marbles, only one red marble, or both are red marbles. So 0, 1, 2. Okay, because we only choose two marbles are drawn without replacement. Okay, that is the concept for random variable. Okay, we denote ataupun we list what is your possible outcome, your S, sample space, okay, and then we find what is your capital X. Okay, capital X is your random variable, represent above. And then what is your small x, the value? Okay, instead of we list BB, BR, RB, RR, you want to find, you assign a value. Okay, either it can be 0, 1, or 2. Okay, again, you already learned about discrete and also continuous random variable. Okay, so the first part is on discrete random variable. Okay, pemulih ubah rawak discrete. So discrete, when we mention about discrete random variable, okay, number of countable sign, it can be measurable, okay, and then you have a whole number. It can be either 0, 1, 2, 3, and so on. Okay, if we discuss about continuous, so continuous, it can be the value, it can be in terms of interval, decimal point, or fraction. So that one is continuous. Okay, but if you have a discrete, whole number, so nombor bulat 0, 1, 2, and 3. Okay. For example, number of children in a family. So it can be either no children, only 1, only 2, and also 3, and so on. Okay. Or it can be number of defective atom, okay, found in 30 electrical components. So it can be 0, 1, 2, and 3. So number of car accident in 1 hour. Okay. Also, it can be either no car accident, only 1 car accident, 2, and so on. Okay, there is no 2.5 or 3.5. Okay, so that one is a discrete random variable. Okay, bilangan nombor yang tepat. Okay, so now this one is your discrete random variable. So now we discuss a discrete probability distribution. Okay, we already seen the example on the coin. Okay, so tossing a coin for 3 times. Okay, so this is your outcome. Okay, again, X here, your random variable representing the number of hits. Okay, it can be either 0, no hit, 1 hit, 2 hits, or all 3 hits. Okay, so this is your possible outcome. H, 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 T, and so on. Okay, so now you want to find what is the probability. Okay, kita dah tahu what is your capital X, and then what is your small x in here, which is 0, 1, 2, 3. Okay, because you're tossing a coin for 3 times. Okay, so you want to find your probability. So probability of getting hit, hit, hit. So half, half, half. So that's mean 1/8. Tail, hit, hit. So same thing, one half, one half, one half. So you have your probability distribution. Okay, this one. So you will find probability x equal to 0. So that means no head. So all is 3 tails. Okay, 1/2 times 1/2 times 1/2, which is 1/8. Either you only have one head, so HTT or THT or THH. Okay, so each one is 1/8, 1/8, 1/8. So you have 3/8. Okay, last you have probability x equals to 2. Again, 2 head, HHT, THH or HTH. So again, 3/8. And the last one, um, 3 heads. So HHH, which is 1/8. So this, you summarize your probability. So you give in terms of probability distribution, table of probability. Okay. Once you already find, okay, katakan first, kita listkan all possible outcome. Okay. Second, you find the probability. Okay, ini second lah. Okay, second, you find the probability. The first one, you list all the possible outcome. Okay. The third one, you summarize in terms of a table. Okay, so that means you have probability x equals to x, your small x, x0, 1/8, 3/8, 3/8. And then again, total probability must equals to 1. Okay, cannot exceed 1. So if this one exceed 1, you have to double check your answer. Okay. Okay, so that is the example for a coin. Okay, you have x equals to 0, 1, 2, 3, and then you listkan probability x equals to x, 1/8, 3/8, and so on. So check total probability must equals to 1. So that is the concept for random variable. Okay, so let us consider another experiment, okay, in your module. So this one, a semiconductor manufacturing process. Okay, 2 wafers from a lot are tested. Okay, each wafer is classified either pass or fail. Okay, the probability a wafer pass the test is 0.8 and the process are independent. Okay, once we have the term for independent, actually you can multiply the probability when you have the intersection. Okay, you can multiply the probability when you have the intersection. Okay, let's say we define a random variable x, which is number of wafers that pass the test. Okay, it represents number of wafers that pass the test. You only have 2 wafers. Okay, what is your small x? Okay, you have 2 wafers. Okay, you represent capital X is number of wafers that pass the test. So it can be either no wafer pass the test, so 0, only 1 wafer pass the test, or all 2 wafers pass the test. Okay, so small x should represent 0, 1, and 2. Okay, that's settled. You already find the value of small x. Okay, so now you want to find the probability. Okay, first wafer, second wafer. So the outcome, kita listkan all possible outcome. It can be either pass, 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 fail, fail, pass, or fail, fail. Okay, probability wafer pass the test 0.8. Process are independent. Okay, so that means 0.8 times 0.8, so you get 0.64. So again, this one, 0.8 times 0.2, 0.16, 0.2 times 0.8, so 0.16, and then 0.2 times 0.2, you have 0.04. Okay, small x, that means 2 wafer pass the test, only 1, 1, and then 0. So this is your small x. Okay, and then you again listkan you all punya probability. So you have probability x equals to 0, which is 0.04, x equals to 1, 0.32, x equals to 2, 0.64, and then you check the summation. Okay, symbol summation. Probability x equals to x is equals to 1. Okay, so that means this satisfies as a discrete probability distribution. Okay, if you want to draw, okay, kata kita nak draw atau kita nak sketch lah. So this is your probability. So this again your values. Okay, values for x. So x0, 0.04, x equals to 1, 0.32, and then x equals to 2 is 0.64. Yeah. Okay, the set of ordered pairs is a probability function. Okay, for discrete random variable, okay, we can call this one as probability function, or we also can call this one as probability mass function. So maksudnya this one you can call as if we use the abbreviation, yeah. So PMF. So PMF stand for probability mass function. So if we have probability mass function, so that means that is the probability function. Okay, probability function. Okay, you can either writing probability x equals to x ataupun small fx. So this one is your probability function. So probability mass function is the probability function for a discrete random variable. Okay, discrete random variable. So again, the properties. Okay, properties for discrete probability distribution lah, yeah. Discrete probability function. So all probabilities must be greater or equals to 0. So you want to check whether fx is greater or equals to 0 or not. Okay, and then second, total probability must equals to 1. Okay, total probability must equals to 1. Then you can say that your x is your probability x equals to x is a discrete probability function. If it satisfies all probability must be greater or equals to 0, and then total probability must equals to 1. Okay, both must be satisfied. Okay, dua-dua ni kita kena satisfy kan dia punya properties. Okay, word condition. Okay, let's say if we refer to the example. Okay, just a simple one, eh. Okay, this one you have a probability distribution ataupun probability function, eh. Probability x equals to x, 5 minus x over 10. Okay, you already have the x values. So x equals to 1, 2, 3, or 4. Okay, again, how you want to identify whether this one is a discrete? Because we have x equals to 1, 2, 3, or 4. Okay, the whole number. Okay, nombor bulat 1, 2, 3, 4. Okay, so that means this is a discrete probability distribution. Dia punya value tu. Okay, build up the probability function. Okay, you just substitute probability x equals to 1. So 5 minus 1, 4 over 10. Probability x equals to 2. So 3 over 10. Probability x equals to 4. So 5 minus 4 over 10. So 1 over 10. Okay, so you check. The total probability is equals to 1. So property 2 is also satisfied. Okay, property 1 tadi, you punya fx must be greater or equals to 0. Okay, so both satisfy. So that's mean probability x equals to x is a probability function, or we can conclude that this one is a discrete probability function. Okay, so that one. Okay, kita satisfy dulu dia punya properties. Okay, now you already list your punya summarize your punya table. Okay, you want to find probability x less than or equals to 3, and also finding probability x greater than 3. So x less than equals to 3. Okay, x less than, so it can have either x equals to 1, or, so we addition, probability x equals to 2, or probability x equals to 3. So from your table, you use your table. So 3 over 10 plus 2 over 10 plus 1 over 10. So you have, 4 over 10 plus 3 over 10 plus 2 over 10. So you have 9 over 10. Okay. So the next one, you want to find probability x greater than 2. Okay, x greater than 2, which means does not include 2. Okay, so it should be either 3 or 4. So probability x equals to 3 plus probability x equals to 4. So 2 plus 1. So you have 3 over 10. Okay, based on the table of your probability distribution or probability function. Okay, probability x less than equals to 3. So that means we start your x is starting from 1. So 1 to 3. Okay, x greater than 2. So it can be either 3 and 4. Okay, so 2/10 plus 1/10. Okay, so that one. Okay. So actually it's the same thing if we have probability x greater than 2. Okay. Okay, probability x greater than 2, you also can have equals to 1 minus probability x less, sorry, probability x less than or equals to 2. It's the same thing. Okay, because we have probability x greater than, so again, your concept is total probability is equals to 1. Okay, greater than 2, that means does not include 2. So 3 and 4. So 1 minus probability x equals to 1 plus probability x equals to 2. Okay, maksudnya kat sini, 1 minus probability x equals to 1 minus probability x equals to 2. So it should have the same one. 1 minus 7/10, so which is 3/10. Okay, so you can have either x greater than 2, 3, and 4. Or again, you can use the concept 1 minus, which is 1 minus probability x less than or equals to 2. Okay, so for a discrete random variable, having the equality sign or without equality sign is important. Okay, for equality ada dia punya equality sign, tak ada equality sign tu very important for a discrete probability function. Okay, tapi kalau continuous mungkin berbeza. Okay, for discrete kita kena tengok. You have to check whether we have the equality sign or not. Okay, for example, let's say you want to find probability x greater than or equals to 2. So that means you will have x equals to 2, x equals to 3, until you have x equals to 4. Okay? Okay, so, or you can have probability x greater than or equals to 2. Okay, let's say saya contoh sini. Okay, probability x greater than or equals to 2. The same thing. You have 1 minus, tapi 1 minus dia sekarang adalah 1 minus probability x less than or equals to 1. Okay, but since you already start your x equals to 1, so just probability x equals to 1 je lah. Okay, so it's the same thing. If you have x greater than or equals to 2, so that's mean include 2, 2, 3, and 4. So total probability 1 minus probability x less than or equals to 1. Okay, so the same thing. So itu kalau kita guna konsep total probability. Okay, we refer to the next example. Example 3.2. Okay, you have 5 black balls and 2 green balls. Okay, 2 balls are drawn with replacement. Okay, maksudnya ambil, masukkan balik. X represent number of green ball. Okay, you draw a tree diagram. So again, you have black balls, green balls. So black ball, you have 5/7. Green ball, you have 2/7. So second branch, okay, of your tree diagram. So again, black and green, black and green. So again, process with replacement. Okay, maksudnya di sini ambil, masuk balik. So again, sama. So 5/7. So this one pun still 2/7 for green. Okay. So write the probability distribution. Okay, your X represent number of green balls. Okay, number of green balls. Okay, 2 balls are drawn with replacement. So X represent number of green balls. So it can be either there is no green ball, only 1 green ball, or 2 green balls. Okay, X0, 1, 2. Okay, this one dia punya small value. Okay, you just want to find probability X equals to 0, X equals to 1, X equals to 2. Okay, let's say probability X equals to 0. So that's mean no green ball. So both are black ball. So 5/7 times 5/7. Okay, probability X equals to 1. So it can be either green ball or black ball second, or you can have either black or green. So 2/7 times 5/7 plus 5/7 times 2/7. Okay, lastly, 2 green ball. So both green balls, so 2/7 times 2/7. So we have 4/49. Okay, so present in terms of your table. Okay, again check all probability greater than or equals to 0, and then you punya summation probability is equals to 1. So then it satisfies as a discrete probability function. Okay, so itu example of the yalah, black ball, green ball. Okay, so process again you check either with replacement or without replacement. Okay, so again this one is with replacement. So ambil, masukkan balik. Okay, so that's mean dia punya number of sample space tu tetap sama lah. Okay. Okay, we just look at the third example. Okay, if there is no question, I just proceed. Okay, example 3.3. Okay, some problem you can represent in terms of tree diagram. Okay, some you can just extract the information. Okay, depends lah. Okay, this one, an overseas shipment of 7 foreign automobiles contain 4 that have slight paint blemish. Okay, so receive 3 of these automobiles at random. So kita listkan dia punya sample space as using the letter B and N. B for blemish and N for none. Okay, X represent the number of automobiles purchased by the agency with paint blemish. Okay. So again, dia just ni you have 3 3. Okay, 3 agency only receive 3 automobiles. Okay, at random. Okay, list down your sample space again. Okay, kalau nak buat macam ni pun boleh lah. 3 diagram. Katakan PN. So ini first. And then second PN. Okay, benda yang sama lah. Okay, you can list down your sample space dulu. Okay, so we have either BBB. Okay, B and B, BBN, and BB, and NB. Okay, so that's mean you already have 8 possible outcome. Okay. Okay, 2 choice, but you have 3 of these automobiles, so you have 8 possible outcome. So your X represent the number of automobiles. Okay, we only receive 3. So it can be either no automobiles with paint blemish, only 1, 2, or all 3 paint with blemish. Okay. So you have small x is 0, 1, 2, and 3. Okay, now you want to find the probability. Okay, you want to find the probability. Okay, again, the process is without replacement. Okay, so as usual, we can draw a tree diagram to depict the process of getting all the possible outcome. Okay, ataupun we can use the concept of the combination rule. Okay, from chapter 2, which is for probability, NCR. Okay, nak buat dapatkan probability macam biasa pun boleh, ataupun nak guna konsep dia, kita guna konsep combination rule. Okay, so let's say probability, okay, kita tengok ini dulu lah, probability X equals to 0. Okay, probability X equals to 0, you have here, okay, you have 7 automobiles. So that means your capital N here is equals to 7. Okay, 4 yang paint with blemish. Okay, none, you have 3. Okay, your sample space, that means you have number of sample space. You will have 7, choose 3. Okay, 7 automobiles, you only receive 3. So number of sample space is just 7, choose 3. Okay, so now you want to find probability X equals to 0. Okay, X equals to 0. So X ni represent number of automobiles purchased by the agency with paint blemish. Okay, yang blemish kita ada 4. So X equals to 0, so that means 4, choose 0. Okay, the balance you have 3. Okay, choose another 3. So divide by 7, choose 3. So simplify, you will get 1/35. Okay, so again, if only probability X equals to 1. Okay, 1 paint with blemish. So 4, choose 1. Balance is 3, choose another 2. So divide by total of your sample space. Okay, ini pun sama. Probability X equals to 2. So that's mean 2 yang blemish. So 4 from 4 we choose 2. So the balance times 3. Choose another 1. Divide by total of sample space. Okay. So listkan semua. Again you check total probability is equals to 1. Okay. Or you can, ini by combination rule Tapi if you want to multiply direct probability pun is okay. Okay, for example X equals to 0, that's mean no blemish. So N. Okay. So again N tadi kita ada apa? None. You have 3 Okay, process je tadi without replacement. So that's mean 3 over 7 times 2 over 6 times 1 over 5. Okay, this one probability X equals to 0. Tiga-tiga tu adalah non-blemish. Okay, so that's mean you have 1, 3, 2 Okay, so cancel. So again you have 1 over 35. So ini pun sama, probability X equals to 3. So all 3 are blemish. So again you have apa tadi? 4 blemish. So again you will have 4 over 7 times 3 over 6 times 2 over 5. Okay. Okay, so you have 4 over 35. Okay, you can find the probability either using the combination rule or you can just multiply the probability. Okay, from the tree diagram. Up to you. Okay, as long you came up with the probability here. Okay, kalau let's say nak guna combination rule, tunjukkanlah cara dia. Macam mana kamu dapatkan dia punya probability. Not simply just put the value tunjukkan cara dia, kaedah dia macam mana. Okay, ini pun sama. Put write the